Hey guys, welcome to section 4, chapter 9 of the geometry program. And in this section, we're going to study vectors. And vectors are things that you typically see in a lot of the sciences, especially physics. But we're going to be able to apply some of our trigonometric ratios and play around with them a little bit. So a vector is any quantity with both magnitude and direction. And it's important that you recognize that there's both there. All right, magnitude is defined as the distance between an initial point and a terminal point. So if you're just looking at array, is what we call it mathematically, the initial point is that starting point, and where the arrow tip is, that's your terminal point. And then if we actually put that on a coordinate plane, which is what we're going to do today, you'll have to identify this is the initial point and the tip of the arrow here as your terminal point. Okay? And that's how we're going to be able to find both magnitude and direction. Okay. First off, they're going to ask you to describe vectors as ordered pairs. So you notice the coordinate plane, you have a vector centered there at the origin, and you even have an angle measure given of 45 degrees. So if you want to describe this vector, you have to grab the terminal point, and then what we're going to do is create a right triangle. So go ahead and drop down a line and form that right angle so that we have a right triangle. Now we can use our trig functions to be able to find both the x and the y coordinate of this vector. All right, so you can, again, play around with them, decide what you want to use, but I typically grab the sine and the cosine. So again, in reference to our measured angle here at 45 degrees, I have the adjacent side and the opposite side that I'm solving for, and the hypotenuse is what is given. So I'm going to use the cosine of 45 to solve for x, because that's my adjacent over my hypotenuse. And then I'm going to use the sine of 45 to solve for my y, which is the opposite over the hypotenuse. Now, in order to be able to solve these, we simply multiply both sides by 100. So I'm going to get 100 cosine 45 equals x. And similarly over here, I'm going to get 100 sine of 45 equals y. Now, if you just put those into your calculator, you can do it even as a single line. And round to the nearest tenth, you should get like 70.7 for your x. And for your y, you should also get 70.7. And so written as an ordered pair, you would get this. Now, do you think it's strange that we actually got the same value for x and y? You shouldn't, because in a right triangle where one angle is 45 degrees, the other angle also has to be 45 degrees, meaning both those sides have to be the same. Okay, let's do one more example like that. Let's say we have a guy down here in the third quadrant, and we want to find the coordinates. We're going to go ahead and form our right triangle here. This is my x, and this is my y. I'm going to use the same thing. I'm going to use my cosine for the x and sine for the y. So I'm going to do cosine of 15 equals my adjacent side, which is x, over the hypotenuse, which is 350. And the sine of 15 is the opposite, which is y, over the hypotenuse, which is 350. And I'm going to do the same thing. I'm going to multiply both sides by 350, just like I did in the last problem with 100. So you get x equals 350 cosine 15, y equals 350 sine of 15. When you put that all together, you're going to get x equals 338.1 and y equals 90.6. As an ordered pair then, it would look like this. 338.1, comma, 90.6. All right. And actually, as a little side note, you could test the Pythagorean theorem here to make sure that you've solved these correctly. So if you did x squared plus y squared equals c squared, which is that hypotenuse, these values should be very close. Again, they're decimal approximations, so it's not going to be exact, but the answer should be very close. If your answer is not very close, then probably you did something wrong. Okay, so you're going to be able to find the ordered pairs of vectors, and then it's going to ask you to use what we call compass directions to describe the direction of a vector. All right, these can be very confusing for students. So it's important that we orient ourselves with respect to the axes. Otherwise, you're going to screw up your directions. So keep in mind that when you're giving compass directions, you want to always be using the axes north, south, east, and west for our orientation. So you find the axis with which you make your angle. So in this case, that 30 degrees is making it with the east axis. And with relationship to the east axis, I'm north of that. So the compass direction is 30 degrees north of east. Okay, because east is the axis with which I formed this. Okay, similarly over here, my reference angle is here. It's made with the axis facing west. Again, hopefully you know all of your cardinal directions. And with regards to west, I'm south of that. So I'm 40 degrees south of west for this guy. All right, let's do one more. Again, what axes is it associated with? It's the north one, right? And in reference to this axis, I'm west. So I'm 20 degrees west of north. All right, so just make sure that you're orienting yourself with respect to the axis, and I think that you should be okay. So you're going to have to identify them, and then you're going to have to draw them. So it's going to sketch the vector with the given direction. So again, you're going to have to come up with the coordinate plane and recognize, all right, this is going to be the orientation I want to start with. So I'm west. So this is the axis I need relationship with, and I'm 25 degrees north of that. So this is my vector here. I'm 25 degrees north of west. All right, pause the video and see if you guys can do this one by yourself to see if you're getting it. Hopefully you recognize that this is your orientation. This is the axis with which you need to form your angle. And you're west of that, you're west of south here. So your vector should look like this guy. All right. Just a little bit more here. We also will need to find the magnitude and direction of the vector. So that's kind of a vector by its nature, right? Both magnitude and direction. So let's say you're given this vector and the x is 40 miles. The y here is 60 miles. And we need to come up with the magnitude and direction. So you're going to put all of these things that we just learned together. So the first is we got to find this value. And we do that by using Pythagorean theorem. So that's what we did earlier on. So the same thing is going to apply. We're going to have 40 squared plus 60 squared. That's going to equal c squared. And then c is going to equal roughly 72 miles. This is the magnitude of this vector. Okay, but we also need the direction. So we're going to use those compass directions, which involve not only orienting ourselves with the axes, but also notice we're missing the angle here. So this is where we're going to have to use those trigonomic inverses that we learned earlier in order to be able to find it. Now we have all three sides, so we can use any of the trigonomic inverses if you'd like. I'm just going to grab, since they gave me 40 and 60, which is my opposite and adjacent, I'm going to grab the tangent. And I'm going to say the tangent of x, we'll call this angle x, is the opposite, which is 60, over the adjacent, which is 40. All right, now remember, in order to be able to solve for x, we cannot divide by tan. We take the inverse tan of both sides. And then I'm going to get x is equal to about 56 degrees. All right, so my magnitude is about 72 miles. And then my direction is 56 degrees. Now again, we're oriented with respect to east, right? So we're 56 degrees south of east. All right, so that was just putting everything together. Hopefully that's not too bad. And then there's going to be one other thing, super easy, they're going to ask you to do. They're going to ask you to find the resultant of two vectors. And that basically is what you get when you add the two vectors together. Now, how do you do that? Well, they're going to give you two options. The first is in a graph, and the other is giving you the vector in written form. So if you're given the graph, then you have to find the ordered pair at the terminal point of each vector. So all you have to do is count, right? So if we count over 1, 2, 3, 4, 5, 6, and this guy is 6. 1, 2, 3, 4, 5. So this terminal point is at the ordered pair, 6, 5. And then this other guy is at 1, 2, 3, 4, negative 4, comma 1, 2, 3, 4. All right, now to find the resultant, we add the x's and add the y's. So we have two ordered pairs here, 6 and 5. Add the x's, and you get 2. Add the y's, and this is the resultant. You'll notice that when writing vectors, we actually don't use parentheses. We use different symbols to represent a vector as opposed to an ordered pair. Okay, so if you're given the graph, just use the terminal point and find the ordered pair associated with it. And then it gets even easier if they actually give you the set of vectors in written form. So if they give you these two vectors, again, all we have to do is add the x, 3 and negative 4, which is negative 1, and then 1 and 3, which is 4. This is the resultant vector. All right, so that's it. Go ahead and finish up your notes, read through the examples, and begin your assignment.